the volume of prisms and cylinders. So we're interested in figuring out how much space is inside a solid shape. Well, the first thing, there's an important idea that we need to talk about. It has a, I like this person's name, Cavalieri's principle. Cavalieri's principle says that two solids with the same base, shape, and height. I'm kind of paraphrasing a little bit. Have the same volume. So what Cavalieri's principle is telling us is that if we have a right rectangular prism, and we're going to imagine that this stack of books that I have here is a right rectangular prism. So it has a base, the area of the base is the area of the book that makes up the base, and the height is however many books tall this is. What Cavalieri's principle tells us is if I make this stack slanted, does the volume of those books change because I slant it? No. Same base, same height, I've just slanted it. I could slant it a little bit one way and a little bit the other way. The volume of the books change when I do that? No. Still has the same base and the same height. The stack is the same number of books tall. So what Cavalieri's principle tells us is the volume of this rectangular prism is the same as the volume of some kind of slanted prism. Because I'm not changing how much space there is inside. Cavalieri's principle also works for cylinders. So there's my cylinder, my slinky. If I imagine that being full of water, well, if I slant it, I'm not changing how much space is inside. If I make it kind of zigzag shaped, I'm not changing how much space is inside. So we're saying the volume of these solids is the same as the volume of a cylinder. So that's what Cavalieri's principle tells us. So if we remember, when we talked about surface area, we said the surface area formulas that we came up with were for right prisms and right cylinders. Well, our formulas that we come up with today because of Cavalieri's principle, the volume are for any prism and any cylinder. So the volume of a prism, and I'm going to say of any prism. Doesn't have to be right. This can be an oblique prism. It can be a zigzag prism, any shape of prism. The volume, nice easy formula. Base times height. And our volume we're going to measure in cubic units. And the capital B is the area of the base. And H equals the height of the prism. And again, this capital B depends on the shape of the base. If it's a rectangle, we have to find the area of a rectangle. If it's a trapezoid, we have to find the area of a trapezoid. We can have, just like we talked about the other day, we can have trapezoidal prisms, hexagonal prisms like our opener. But we have a nice, easy formula. Area of the base times the height. So let's look at a couple of examples. Here's my prism. And I'm going to draw in the other sides just with dotted lines. So there we go. And I'm going to say this is 6 meters, 5 meters, and 12 meters. All right, what would we call this thing? What kind of prism? What's the shape of the base? And what's the only shape that's there? Rectangle. This would be a rectangular prism. We want to find the volume. For a rectangular prism, does it matter which side we pick to be the base? Don't I have two parallel rectangular shapes that are 6 by 5, the top and the bottom? But I also have two parallel rectangular shapes that are 12 by 5, the two right and left side. But I also have two parallel rectangular shapes that are 6 by 12, the front and the back. So for a rectangular prism, it doesn't matter which side we pick as the base. I'm going to pick this as the base. This. So I'll call that the base. I could call any of the sides the base. We just then have to pick the height based on what we call the base. Well, the area of the base, this is easy. The area of the base is 6 times 5, which is 30. If this is the base, what's the height? Height would be 12, the distance between the two bases. So height would be 12. So the volume is 30 times 12, which is 360 cubic meters. We can also think of this as length times width times height. 6 times 5 times 12. 6 times 5 times 12. So for a rectangular prism, we can think of it as length times width times height. Because length times width is the area of the base. All right, questions there? Rectangular prisms are pretty easy. Let's look at a little different example. Here's my prism for this one. Oops, we need a solid line now. There we go. And I'll draw in the other sides with dotted lines, the sides we can't see. There's my prism, and I'm going to say this is 6 inches, 6 inches, 6 inches, and 10 inches. All right, we want to find the volume in simple radical form. Well, first off, what kind of prism is this? This would be a triangular prism. We have two parallel triangular polygons. So this is a triangular prism. The triangle is the base. Well, that's important. We need to find the area of the base. Well, to find the area of the base, I'm going to redraw it here without it being on the prism. I'll redraw it in blue. There's my base. And this is 6 inches, 6 inches, 6 inches. So that's the base.
So redrawing the base is something that we recommend that you do. That's why Mr. Weaver is showing you. It's a good idea.
Well, we need to, in order to find the area of the base, we need to find the height of the base. We don't have the height here. Well, let's draw in the height of the base. There's the height of the base. What does this segment do to the side, the base of the base? You get a 30, 60, 90 triangle. And what is it? What about this side? Cuts it in half. So this would be 3. We need to go from the short side to the long side of this 30, 60, 90 triangle. This is 30 degrees and 60 degrees. So to go from the short side to the long side, what do we do? Multiply by square root of 3. So the height of the base is 3 square root 3. So the area of the base is the base of the base, 6 inches times the height, 3 square root 3, divided by 2. 6 divided by 2 is 3, and 3 times 3 is 9. 9 square root 3. The height of the prism is what? 10. Between the bases. The height of the prism goes between the bases. The height of the prism is 10. So the volume is the base, 9 square root 3 times 10. I can multiply outside the square roots, so I get 90 square root 3 cubic inches for the volume of that prism. So we had a regular hexagon for the opener, equilateral triangle. All of that stuff from chapter 10 comes back. All right, questions? Okay, let's talk about cylinders. Volume of any cylinder. Cavalieri's principle works on cylinders also. Well, we said the other day, on Friday, that cylinders were essentially like curvy prisms. The formula for our surface area was the same. We just had to take into account that our bases were circles. Volume of a cylinder is exactly like a prism. So our volume is the area of the base times the height, units cubed. And let me draw a cylinder here. There's my cylinder. There's my height. There's the radius of the base. Well, what is the base of a cylinder? What shape is the base of a cylinder? A circle. What's the area of the base? How do we write the area of this circle? Pi r squared h units cubed. Area of our base on a cylinder is a circle. So we have pi r squared times the height. It's exactly like a prism. R equals radius of the base, and height equals the height of the cylinder. All right, so let's look at an example, and then I want to show you kind of another application. And we want to find the volume. And I'm going to say in terms of pi. Well, cylinders are nice because all we really need to know is the base is always a circle, so we always know how to find the area of a circle. What do we have here? What piece of information does that give us? That's our diameter of our base. So the radius is 6 centimeters. So our volume is pi times 6 squared times 14, which is 6 squared is 36, 36 pi times 14. And I'm going to multiply the 36 times the 14, and I get 504 pi cubic centimeters. That would be my volume in terms of pi. If we wanted to round to the 10th, we'd multiply 504 by 3.14159. All right, questions? Okay, let me show you, let's look at one other example. Here's our shape for this one. All right, and we're going to say this is 17 inches. That's 10 inches. That's 12 inches. And that's 11 inches. And we want to find the volume. Well, we think for a second. We realize that we don't have the formula for the volume of a mailbox. So what are we going to do? What's another way we can think about this? Yeah? Right. Right. So what we have here is a rectangular prism plus a half a cylinder. So we've taken a half a cylinder and put it on top of our rectangular prism. We know the volume of the prism equals, we could think of length times width times height, area of the base times height, 10 times 11 times 12, which is 1320 cubic inches. And our half cylinder is 1/2 of pi times the radius, 5 squared, times the height of the half cylinder is 11. And if I leave it in terms of pi, I get 1/2 of 275 pi, 5 squared times 11, 25 times 11. And this is about, if I plug that into my calculator, 431.97 cubic inches. And so the total volume is 1320 plus 431.97 equals 1751.97 cubic inches. What would I get? What would I write if we wanted to round this answer to the 10th place? So to round to the 10th, I need to round this 9 up to 10. So that would give us 752.0 if we were rounding to the 10th. All right, questions? Okay. There's that.